Hello and welcome to Brick Tip number 48 design video. If you saw that video, you saw that this thing can take at least a 180-pound load. I don't know how much further it can go, but we are going to open this up, pull off the roof panels, and I'm going to show you how exactly I designed the interior trusses. Before I get into the trusses, one thing I wanted to note was this brick here. In the old roof, I had actually two plates, but I found I had enough room to put a brick, and that gave more surface area for the other roof to rest on, so that provided a little bit more strength. Not a lot, but a little bit more. And here we have our trusses. So when I was designing the trusses, I had gone and made sure that the spacing was correct for putting a plate across and it would attach no problem, and that was easy enough done. By doing so though, I had inadvertently made enough room to put these top beams in, and the spacing was perfect for beams to go all the way across. Now if you wanted to go really crazy on this, you could actually line bricks all the way down, but you can tell there's really no reason. There's a lot of strength there. And the same within this middle beam. I was worried I wouldn't be able to attach those and connect the beam all the way across, but more by luck than anything, I was able to use a couple brackets and a plate to connect it. We'll pull that out so you can see. So there's the plate under there, and this part in here isn't actually connected. That's just loose. But I wanted to block it anyways so that it would hold up the forces, because if I did that by itself, these are obviously going to pull up. So by just putting that block in there, it made it so that they won't pull up on each other if they're compressed. Here's the construction for that middle beam. I wanted this to be bulkier than the top beams, so I went with 4 brackets, a couple of plates, and then there's just tiles in there, and it perfectly locks into a 2x4, and then I just need another plate for spacing to get it all to line up. So I was really happy with that. Now we can take the truss out. And as I mentioned in the brick tip video for this, they just clip in and out. It's going a little bit further with the truss. You can tell it's much thicker than it used to be. I made sure that everything was interconnected. I had to obviously make room for these hinges, and it turned out that they lined up perfectly with the back of the truss, and that was due to the fact that I mentioned I wanted to make sure that I could connect plates from one truss to the next. So I played with that spacing a little bit, and that turned out to be perfect. So the other truss the same way, you just pull it out. So we're going to get to the main trusses now. There's not much difference between these and the original roof. I did lock them in a bit more with another series of plates, and in the front, even though there was those beams all connecting it, there was still some movement where these trusses were wanting to give a little lateral movement. So what I did was with this decorative element on the outside was use it as a stop so that the truss wouldn't want to push out very far at all. And I had to use some tiles here to get the proper spacing, but it worked out in the end, and this will move a bit, but by the time you get in all the extra beams, there's no movement at all. So we'll look at the walls now. You can see I went much thicker on the walls. Starting at this plate down here, we have 1, 2, 3, 4, 5, 6 thickness, so that's basically the width of 2 bricks. Obviously, you stack plates like that, you're going to get a lot more connection, and it's going to be a lot stronger. I had to fiddle around here and try to find a way to get that hinge connected in and make sure there was room to slot in our trusses, and that is the reason why it got bulked out so much, because I had to use the outside of the frame quite a bit to give it that strength around that joint. And through here I also used just that 1x plate to continue the connection along through the bottom, because I wouldn't obviously be able to connect it on top. Also with this 1x plate, the truss is actually sitting on it. So again, as the force is getting pushed down, it's pushing on this as well. If that wasn't there, you'd have the roof collapsing much quicker than at 180 pounds. So that's the basic design of how I did it. If you want to look at how I constructed the trusses, you can go back to that original roof design. Oh, one thing I should mention is that you can see that the trusses, their mounting points are mirrored to each other. They're not in the same direction. Again, the whole point of that was to make sure that we could get those plates where they needed to go. So tomorrow I'm going to do a video on locking in the walls to the eaves, because that added a lot of strength to both the walls and the roof, and it made it so that compression forces on the corner weren't nearly as strong compared to this. You could hardly even move it. So altogether it created a really, really strong structure. Obviously, as I said in that video, over-engineered. You'll never need to get to this level unless you want to do something like put 200 pounds of weight on top of a roof, but I can't see that happening. But you never know. If you are looking at designing a skyscraper, for instance, this section with the entire roof and everything on it was about 1 kilogram, so a little over 2 pounds. So you'd have to go very, very high to create a skyscraper that would be heavy enough to actually crush the bottom floor. Alright, so that's it for now. Hopefully you found this useful. If you did, please hit the like and subscribe buttons and share it around so others can enjoy it. If you have any questions, please leave them in the comments and I will get to them as soon as I can. You can join in the conversation on Facebook and our other social feeds. And if you wish to support us through Patreon, that would be very much appreciated. Thanks so much. Have a fantastic day. Keep dreaming of bricks. Bye-bye.